give a demonstration of Quality's CloudShell environment as a service married with GigaIO's FabreX high-performance network. The FabreX high-performance network is a PCI Express fabric layer that's designed to interconnect all of your different high-performance computing center assets. This gives you the capability of putting all your different assets, NVMe flash, CPUs, servers, GPUs, all those different pieces onto a fabric that is PCIe Express based. This gives you the same performance as if it was on the motherboard on PCI Express. It gives you the same sort of ultra low latency and ultra high bandwidth. And married with CloudShell's asset management capabilities, this turns your high-performance computing center from a one-size-fits-all into a recompostable stack. So if you have a high-performance computing center that is a co-tenancy, you can basically now go from that one-size-fits-all, where you have sometimes jobs that are overutilizing some assets and underutilizing others, to tailoring your assets made available to the different jobs based on what you want to do. This gives you a whole different level of control, of monitoring, of performance and capabilities. One of the way CloudShell approaches this modeling is through something called blueprints, and these are what we're looking at here. This is a blueprint catalog specifically for GigaIO. The blueprints themselves are basically a safe deployment, and they can be tailored from ultra simple, where you start off with a basic set of assets, and you can on demand marry up assets and deploy them as you see fit, to something that's much more complex that you can schedule ahead of time to run a set of assets, deploy that set of resources, go into the server, update configurations, update data, update containers, and run any sort of jobs. So it can be scaled in both directions very easily, and they become basically saved assets that are made available to your users. All of this from CloudShell is run through an HTML5 portal. This gives you also the capability of taking your high-performance computing center and making it self-service. So you don't necessarily have to have people open tickets when they need a system built or a job added or anything like that. It can be a self-service item, which reduces basically your administrative overhead, and it speeds up your clients that are using it because they don't have to wait for anything. They can come in and use it as they see fit. So in this example, we're actually going to go through what's a low-level build, and we're going to add resources into it and go out and deploy it. So we're going to start off with the CentOS build resource. One of the nice things too is that this can come with a full set of instructions, and in this case we're taking a look at what the compute stack looks like. This, on the back end from an administrative point of view, is an HTML5 web page. It comes with a built-in graphical what you see what you get editor, or you can drop in raw code, whatever your level of skill there is, but you can also easily embed any sort of assets that you would like. If you want to embed web pages, movies, you want to embed hyperlinks out to, say, a more detailed help page, or even out to your ticketing system if they need to open a ticket for if they're having a problem with an asset or a resource. You can also embed like a PowerPoint deck in there so they can walk through a demonstration and see what's going on. In this case, we're actually taking a look at our high performance, our demonstration stack here, our high performance compute demonstration stack. So on top, we do have a CloudShell server running, and that's just there to do the asset management system. The performance side of it is we actually have a GigaIO FabreX switch there that makes the interconnection between all the different resources. We have a CentOS machine here. That's one server that we have a Windows server here. We have two banks of GPU units. Each of those are going to have 4 of the NVIDIA K80 GPUs, which have 2 GPU processors on each. And we have 2 banks of NVMe flash storage available to us. So for users, this is something that they can totally compose on the fly. So we can come in here and actually take a look at, from the hover over, this is the top level asset, we can look at the structure. If we want to remove structure, we can simply come in here and click it. In this case, we're going to go ahead and remove these guys. And then I want to add new assets into that. So I just want to start off with this CentOS machine, and I want to build it up to how I see fit. So I can come in here, and from the hover over, I have more options. And I'm going to add sub-resources into the system. And so this is going to slide out, and it's going to give me all the available subcomponents in this high-performance computing stack. And we have all the same ones we just saw on that graphic. We've got our CentOS machine, we've got our Windows server, we've got 2 banks of NVMe flash, and we have 2 GPU banks here available to us. When I'm searching for this stuff, I can narrow it down any which way I'd like. If I want to search for stuff, I can search by asset type or asset name, or I can search if I wanted to by a particular GPU card that was in the bank. This can be done any sort of which way. For our purposes, we're going to keep it really easy today. I'm just going to come in here and drag on the NVMe flash that I want to use. And again, to build it in there, all I have to do is basically drag and drop. I click the structure there to see the update, and I'll come in here and I'll add a bank of GPUs in on there also. And again, I'll come over, oops, that disappeared. Let's pull that back out on the structure. And we can see now that we have our bank of GPUs there, which is the 4K80s, and we have NVMe flash here, which is 56 terabytes of flash, and that's going to be married to that CentOS server, and it happens to be running Kubernetes on it. So from this point, if I want to go ahead and deploy it, I can basically come up here and click this reserve button. Now, this is going to give me a whole bunch of different options. Overall, so you understand, the system also is role-based access controlled. So we can limit user profiles to what assets they see and when they can use them and how often they can use them. All those controls are built into the system over, and that then will give access to your high-performance computing center. So all those rules get inherited to those access. For a user, if you just want a quick, hey, I just, I want this for, like 6 hours, 5 hours, I could just click and go. Right? If I wanted to add a reoccurrence, I wanted to do it, every day, or if I wanted to do it on particular days, let's say I wanted to do it every Saturday, you can set up a reservation to run that periodically. You have any sort of options that way. I'm actually going to hit cancel here real quick and start over because I don't want to do a reoccurrence. Let's say I actually want to, if I want to see some more advanced options, if I want to add other users, you can do notifications on when it's available, things like that. If I want to add an additional user in here, I could add an additional user that have access to my stack. If I'm the admin, I'm actually building it for somebody else. I can change the ownership on that if that's what I wanted to do. Again, you can send out notifications for that type of stuff. We would actually maybe change the name to Chemo's build, right? And let's say I didn't want to run it now, but I wanted to run it, say, next week at actually 9 a.m. or 10 a.m. If I wanted to make that reservation for next week at 10 a.m., I can do that also. If I come in here and go ahead and hit reserve, oh, I see that there's a conflict. So we have automatic conflict. And it's going to tell me, hey, by the way, that particular GPU bank that you want to use, it's being used by Nvance. Oh, okay. All right. So let's cancel this. And let's go and just make ourselves an immediate reservation. So I'm just cancel out. And I'll take it right now. I just need it right now. And I'll go ahead and reserve that. And this is going to go out now and talk to the FabreX system. And it's going to go build our actual deployment on the fly for us. Actually, I don't need that. So this is now going to examine what we have in the system, and it's going to go actually compose it for us. So we're going to let this run through, and we'll come back here and pick it up in just a few moments. system is basically been deployed, it's going to go ahead and ping the host server to make sure that it's there. We see that it's responded. We also come in here and deploy an asset for access. We'll talk about how that works in just a moment. All right. And basically, it also gives us confirmation of what we have deployed and the current state of it. All right, so we can see here that the two assets that we deployed, the system actually came back and said that they were okay and enabled. We get a basic information about what was deployed. So we've got that GPU bank. And it's got the K80s times 4, and then we've got in this 56 terabytes, we know we have 12 Samsung 80 gigabytes, or 12 Samsung NVMe drives at 800 gigabytes each, sorry, and then 8 of the Western Digital drives at 7 terabytes each. Provisioning is overall done and complete. Now, if we actually wanted to access this, this tells us here that we have access to it via SSH. So we come into here and we can basically automatically SSH over into the machine. Now, it is access control, so we do have to log in occasionally back in on this, but it is the user's login. It's not actually the login to the machine. That's actually kept secure. You don't have to hand out credentials. We'll actually demonstrate connecting to it from the Windows machine. It's an SSH terminal. There's nothing special there for this one. In addition, the other things that we can do, let's talk a little bit more about the actual asset here. We've talked about the structure. We can also expose different attributes about the different things in there. And ultimately, we can also expose, we also have a command tab here. And I'm just going to actually collapse all real quick. We can actually expose different commands out to the users, anything that's very simple to very complex. Some common requests that we have is that if you want to do a power cycle, if you want to do a restart and a wait, or if you want to power on or off the server, we can actually make those exposed to the user here. So in this case, this is a restart, and you can specify how long of a restart that you wanted, and you can expose that out to the user. We have a couple other utility commands also embedded here. Again, and this is fully flexible. We can make this do whatever we want it to do based on what whatever your users would need it to do. We have the capability of showing a current configuration, and that's actually the same information that we're seeing here at the end of the screen, which is just gives the user an idea of what they have available to them on that stack. The redeploy, in the event that the user wanted to recompose the system, they wanted to add or remove assets, they could do that, and they could click the redeploy, which would then power off the system, decompose it, and then rebuild it based on what's now in the reservation. So let's jump over to our existing Windows build. No reason, we already have this up and running, so we don't have to wait. So let's hop over here and take a look at what's going on over here. So one of the things that we can do, like we talked about, is we have embedded commands available here for us. And if we wanted to, I'm just going to clear that off. And if we wanted to see the current configuration that we have deployed here, I can just click on that. And it's going to give me the current configuration. So it's going to query the system. It's going to take a look at what the FabreX system sees that it has attached to it and deployed, and we'll see what we have here. So in this case, we have the NVMe flash, 10 terabytes. It's 13 Samsung 800 gigabyte units, and we have the GPU bank here with the NVIDIA Tesla K80s, 4 of them. All right. So that's an example of how easy it is for the user to execute a command on the system. And if they want to basically have access over to work on the Windows machine itself, through the same pane of glass, we give them the capability of RDPing over to that system. And they simply just click onto it, and they're over and into the RDP session. Right here also, we do happen to have the device manager running, so we can see the same bank of GPUs. And the same NVMe drives that are attached to the system. So this gives the user the capability of accessing that without you having to hand out credentials for access to that. It's accessed, basically right here through the same web page, through the single pane of glass for the user. This really enhances that self-service capability. It makes it very easy for a user to find their assets, to deploy and compose the system, and access it through the web page without having to manage anything else beyond just availability of the resources. We invite you to go ahead and submit any additional questions that you might have. and contact us at tsieda.com. Thank you.